Good morning, everyone. Welcome to the class of CE333 Environmental Engineering 2. So, in our last class, we discussed the calculation of discharge from different types of land usages and then infiltration. And from there, we determined the cumulative peak flow, which is Q design equals to peaking factor multiplied by Q average plus infiltration. The Q design or Q peak, this is actually this column 34. So from there, I was showing you how to calculate the diameter. First of all, let's do it again. You know your flow, number A. Number B is ground slope and minimum slope, which is in our case 0.0008. Okay. So if we go back to the here, our ground slope is 0.0008. One triple zero 5 6 7 8. Are you following me, guys?
Yes, sir.
Yes, sir.
So that means you cannot go below this line. You cannot go below this line, right?
Yes, sir.
Yes, sir.
Okay. Then minimum velocity. Okay. First of all, cumulative peak flow, which is what, guys? 0.121. 0.121. Where is 0.121? 0.1. This is 1. 0.1. This is 0.1. This is 0.2, right? So 0.121 should be around here. Now you cannot go below 0.121. Am I right? Because your load coming is 0.121. Can you go below 0.121? Guys, can you go below 0.121? In the sewer, are you following me?
Yes, sir.
Yes, sir.
You will have 0.121. Anyhow, you'll have to meet this demand. So can you go below 0.121? No, you cannot go, right? So left of this red line is less than 0.121. So you cannot go below this line, right?
Yes, sir.
Yes, sir.
Similarly, you cannot go below this yellow line. So this is cross mark. Let's use this cross. You cannot go below this line. You cannot go below this line. So available area is only this, am I right?
Yes, sir.
Okay. Then what? Peak flow ground slope and minimum slope, minimum velocity, and available diameter in market. Fine. Now we need to calculate the sphere diameter. And what was your our slope? Uh, if you go back there in the map, where is the map? Here is the map. So pipe 1 and pipe 2. Pipe 1, pipe 2. So 20 and 19, right? So this is 20, same datum. This is what, guys? 90.
90.
So what will be this value? 20 minus 19, right? And
Yes,
this is
sir.
what? 707. So slope is what? Vertical divided by horizontal. Vertical equals to 20 minus 19 and horizontal is 707. Can you please tell me the value, guys?
স্যার নিচে কত লিখেছেন 70.7?
707.
স্যার 0.0014.
0.0014. So 0.001.002. 0.001.002. So 0.0014 may be here, right?
Yes, sir.
So remember your available area is up to this. Your discharge line is here and this green line cuts where? Here, right?
Yes,
It-
sir.
Sir.
Okay. Point 121 should be, I think, here, right? Point 121. We're far below that line here. This is point 1. This is point 1. And this is point 2. So point 121 should be here, right?
Yes, sir.
Okay. Now, as you look at this line, this green line already cuts this point, right?
Yes, sir.
And this has automatically coincided in the line for 50, right?
Yes,
For
sir.
and 450 millimeter diameter. And is this point within the permissible zone? This is your permissible zone, right? Is this your permissible zone? Yes, within the permissible zone. If you were here, then it's not permitted, right? Outside of this box, you are not permitted. Am I right?
Yes, sir.
Sir.
Because you cannot go below this line. This is cross. Similarly, you cannot go left of this line. So this is cross again. Your only available area is this. Okay, this. Are you following me?
Yes,
Yes,
sir.
sir.
Yes, sir.
So now we can see that we have fallen where this point. So this is within the permissible zone. So we are right. We are good. Okay. And also this line intersects the line of 450 millimeter diameter exactly. So 450 millimeter diameter is available in the market, right?
Yes, sir.
Yes, sir.
So we are done. Look at this. Our suet diameter is 450 millimeter. Our slope is 0.0018. For this point, the slope is 0.001. 0018, right? 120. 0018. So I think the line will be a bit higher. That 001.002, so 0.0018 maybe here. Okay. So instead of this point, we are at this point here, right?
Yes, sir.
So no problem. This is still 0.450 millimeter, 0.0018 slope, and the velocity is what, guys? Tell me the velocity for this point. What would be the velocity? Hmm? This is the velocity line.
Sir, 405,
For,
450.
for this point, this is the diameter line, by the way.
So 0.75.
0.
0.75.
Has
0.75,
0.75.
0.75, because this is the velocity line, okay, and this is the diameter line. The diameter this is 450, but for velocity this is 0.75. So sphere diameter 450 and sphere slope is 0.0018, velocity is 0.75. Now tell me one thing. At this point, what is the full, what is the capacity of the pipe? Full capacity of the pipe. At this point, the full capacity of the pipe is 0.121, right?
Yes, sir.
So this is exactly similar to the flow that is coming. If these two are similar, then you don't need to have a partial check, partial flow check, right? But if this is higher and if this is smaller, then you need to provide a partial flow check. Very important. If this one is higher than this one, then you need to give a partial flow check. Clear?
Yes,
Yes,
sir.
sir.
Yes, sir. Similar হইলে
I'm sorry.
দুইটা এক হইলে সিমিলার হইলে
If this is similar, then you don't need to provide partial flow check. Why? You have to understand why. This is your shear. Now the capacity of the sphere is, for example, 0.121. This is the capacity. Capacity is 0.121. Clear?
Yes,
Yes,
sir.
sir.
That means if you provide 0.121 meter cube per second in this pipe, then the pipe will be full. Did I make it clear?
Yes, sir.
So this is full flow. Why do you need to have a partial flow check? This is full flow, right?
Yes, sir. বুঝতে পারছি।
Now, if you provide, this is the capacity 0.121, but if your flow here is less than 0.121, any value less than for example, 0.1, that means in that case, is the pipe going to be full ever? The water level will always be below the full level. Am I right or wrong?
Right.
Right, sir.
So is it a partial flow or full flow?
A partial flow.
Partial
Partial
flow, sir.
flow. So you need to provide a partial flow check. How? I will show you in the next in the next section on the next calculation. Did you get my point, guys?
Yes, sir.
Yes, sir.
Okay. And always remember that this nomograph is giving you the full flow parameters. All parameters, whatever you are getting here, these are full flow parameters. For partial flow, you need to use the partial flow diagram. Of course, you need to nomograph first, and then using those values, you have to use the partial flow diagram to calculate the partial flow parameters. Okay, fine. To be clear, once I show you another calculation, let's say this one, 0.314, guys, 0.314. What is this? Discharge 0.314. So cumulative peak flow is 0.314. Let's look at this. What is 0.314, guys? Point 1, point 2, point 3, point 4. So 0.314 should be here, right? Be here.
Yes,
Yes,
sir.
sir.
0.314. You cannot go below, you cannot go left of this line. That means below 0.314. Hmm? So this portion is cross. You cannot go left. You have to be right of this green line. Okay. Now what? Ground slope and minimum slope. Okay. Let's provide it that slope minimum slope is what? 0.0008, 0.005678. That means this. So you cannot go below this line. You cannot go below this line. Are you following me?
Yes, sir.
Yes, sir.
So only available area is this. Okay, this is the only available area. Now, ground slope. What is the ground slope here? Let's see. 2 to 3, right? What is the pipe, by the way? What we're doing here? We're doing it for 2 to 3. Okay? And for 2 to 3, the total flow is 0.314 and length is 707. So for 2 to 3, right? For 2 to 3 here. So slope is what, guys? Tell me. 2 to 3. 19 minus 18, right?
Yes, sir.
Yes, sir.
19 minus 18 divided by 707. Tell me the value, please.
0.0014.
Is it correct, everyone?
Yes, sir.
Yes, sir.
Okay.
0.0014.
0.001. Point zero zero one. Okay. Now look at this. You are here. This green line and this red line cuts here, right? You are here. Are you following me?
Yes, sir.
Yes.
Yes,
जी
sir.
सर.
Yes, sir.
Now your available area was what? Your available area is this green and this minimum slope line and this green minimum velocity line. So this is your available area. Okay. You are here, right?
Yes, sir.
So no problem. But there is a problem. The problem is, look at this. Exactly, this doesn't fall either in this line or in this line, right? This point, neither fall in this line or this line. In between, right?
Yes, sir.
Yes, sir.
So is this available in the market, this diameter? No. In the market, the available diameter is 675, either 675 or 750, right?
Yes,
So
sir.
Yes,
what
sir.
you have to do is, um, of course, you have to be in this area, in this zone. Now, either you can go here and take 675, or you can go from there to there and it takes 750 millimeter diameter. Are you following me?
Yes, sir.
Yes, sir.
This is your point where they have cut. This is the point where they have cut, but this is in between 675 and 750. So, oh, another thing, guys, I forgot to show you. What is the minimum velocity line, guys? What is the minimum velocity line?
0.752 to be sure.
0.75. Fine. So, you also have to draw that line. Mm, let's take this one, 0.75. 0.75. I already write it down here. Look at this. minimum velocity. You see? Minimum velocity. So your available area will be this, and then this. This will be available area. You cannot go below this line also, right? Is it clear?
Yes, sir.
So now you have cut in this point. It doesn't fall either in 675 or 750. So what you can do is you can either go there in this point or go there at this point. If you are here, your diameter will be 675. If you are here, your diameter will be 750. And since both of these 2 points are within the permissible zone, so you are good, right? So technically, both of these 2 points are correct. Are you following me?
Yes, sir.
Now the
Yes, sir.
question is, which one would you take? Tell me, which one would you take? Both are correct in terms of technical prospect. In terms of technical prospect, both are correct technically because both of them have fallen. Both of them have fallen in the permissible zone. Which one would you take? Any idea?
Sir, 675 millimeter এটা ওটা
675, right? Why?
সেটা ডায়ামিটারটা কম আর কি খরচ
কম
কষ্ট কম
আসবে, কস্ট কম আসবে পাইপের, রাইট?
জি স্যার
Okay, but there is a but. Look at this. Although at this point your diameter is small relatively to that one, but in for this point, what is your slope requirement, guys? Around 0.0015. But for this point, although the diameter is higher, the slope is 0.001. That means here your pipe cost will be small, but earthwork excavation cost will be higher. And here for this pipe at this point, although your pipe cost will be higher, the earthwork excavation cost will be smaller because the slope is 0.001 here. Am I right?
yes sir
Now,
Yes, sir.
as a net basis, as a whole, as a combined form, which one is going to be cheaper? You need to do both of them. First of all, you take this, okay? You take this diameter and you take the slope and you calculate how much earthwork excavation you need. For example, this is the ground, okay? This is the ground, and your sewer is going to lay out in this direction. Hmm. uh, S equals to what? 0.0015, for example, in our case, right? For this point, 0.0015. Now, what you can do here is this. For this slope, usually we cut the soil using this trapezoidal shape. Okay. Okay.
Yes, sir.
So
Yes, sir.
you'll have to cut the soil from here all the way up to there, and like this will be like this, right? So you can calculate the volume, am I right?
Yes, sir.
Yes, sir.
From there, you know the length. For example, if this is 707, you know the length. First of all, you have to calculate the area, and area here and area there, and then you need to multiply this with the length. Okay. Now this side slope, you can assume this is 1:2. Hmm. What is the depth? This depth height is maybe 2 meter approximately. This height is 2 meter. In the next section, you'll get to know what is the exact height here. Okay, I'll show you. So you know the height, you know the width here. I'll show you what is the width, and you know the slope here. So you know trapezoidal area equals to what, guys? If this is the bottom width, if this is the bottom width, then B plus SH into H, right?
Yes, sir.
Okay. Uh, Sometimes if this is not that much high, like less than 6 feet, this height is less than 6 feet or 7 feet, then instead of trapezoidal, we can also cut it like rectangular shape, no problem. Then your area will be B into H. This is B, this is H. Simple. Okay, clear, guys?
Yes, sir.
So you calculate these. So from there, you will be able to calculate the volume of the earthwork excavation. Now you know that per unit volume earthwork excavation, your cost is X taka per meter cube. Now if you have 40 meter cube, calculated 40 meter cube, then your total cost will be X into 40. Am I right? For 1
Yes, sir.
meter cube, cost is X taka. For 40 meter cube, the cost will be 40 into X. Right? And also you know the cost for 675 millimeter diameter pipe. Similarly, for this point, you calculate the earthwork excavation cost, and you calculate the cost for 750 millimeter diameter pipe. Then you compare the cost this and this. The cheaper one will be taken. Clear?
Yes, sir.
In the exam, you can take either any of these two. You do not need to provide this check, cost check, but you have to show the partial flow check. Okay.
Yes, sir.
I will give you a project where you will have to show everything. This cost check, you have to provide it in the project. But in the exam, since you do not have much time, so you do not need to give this economical check. I mean, cost check. Clear?
Yes, sir.
Okay. Now, there's one issue. Technically, both were correct, right? This one and this one, technically both are correct. Now my question is, if you take this point, this one, okay, what is your capacity, guys? 123.314, right?
Yes, sir.
Okay. And what is the flow coming? 0.314, same, right? Right?
Yes, sir.
Okay, fine. But if you take this one, this point, then what is your capacity, guys? Greater than 0.314, am I right?
Yes, sir.
Yes,
This
sir.
point is a bit right than this point. So your capacity may be 0.34 something. This is 0.314 and this is 0.34. Okay. 0.34 or 0.33. That means they are taking which diameter, guys? They are taking this point. That means they are taking 750 millimeter diameter. Am I right?
Yes, sir.
Okay. So they are taking 750 millimeter diameter. Fine. So for this point, the slope will be what? They are taking this point, remember. Okay. For this point, the slope is 0.001 approximately. So slope is 0.001 or 0.0009. It's close. Okay. Okay.
Yes, sir.
Okay. Now my question is, since you have taken this point, your full your capacity of the pipe is 0.314. But what is the flow, maximum flow that you will get, guys? Here, the maximum flow that you will get point. I'm sorry, I wrote it wrong. 0.314 is not the capacity. What is the capacity, guys? For this point, the capacity is 0.33 or something like that, right? This point,
Yes, sir.
0.33. And what is the maximum flow that you are getting here?
0.314.
0.314. So the maximum flow that you are getting here is 0.314. Now the question is this sewer ever going to have the full flow?
No, sir.
No, because capacity is 0.33. Maximum flow that is coming, that is 0.314. That means the flow level will always be below the top level. So this will be a partial flow condition. Now, due to this partial flow condition, you know, the velocity that you are getting at this point is what, guys? The velocity for this point around 0.75 here, right? You are here, right?
Yes, sir.
0.76.
0.7511, maybe 0.78,
871.
right?
0.78, sir.
Yeah, 0.78. But the question is, zero point 0.7 is for what condition? The 0.7 is for this condition when the flow will be at the top. Then the flow will be what? 0.78. Clear?
Yes, sir.
When it is a full flow, that means equal to the capacity, then this is the 0.78. But since your flow is less than the capacity, which is 0.314, that will be partial flow velocity Vp. This is V full. Are you following me?
Yes, sir.
Now you have to check whether your this flow, actual flow, is greater than or equal V minimum, because you cannot go below V minimum. So you must ensure this, right?
Yes, sir.
Okay. So what would you do? Um, Same. We have already done this. You have to go to the partial flow diagram. But before we go to the partial flow diagram, this is what? Small q, right? Partial flow. And this is the full flow, right?
Yes,
So
sir.
we know the q by q, right? What is q by q, guys? 0.314 divided by 0.33. Can you please tell me the value?
Sir, 0.95.
0.95. Great. 0.95. And what is your v full divided by, sorry, v partial divided by v full? We don't know, right? We don't know. We only know v partial. We do not know v full. Okay, no problem. We know this q by q. Knowing this, let's go to the partial flow diagram q by q. Here. What is the discharge graph? This is the discharge graph. Now 0.95, right?
Yes, sir.
0.9 and 1. So 0.95 should be here. Should be here, right?
Yes, sir.
Okay. Now you draw a horizontal line from there. Okay.
8.4, 0.84.
Now
Maybe.
look at this. What do we want to know? We want to know this. So let's calculate this now. Determine this. Where is the velocity graph? Here is the velocity graph. So where is this guy value, guys? Approximately 1.1, am I right?
Yes, sir.
1.0, 1.2, 1.1. Okay, that's fine. So this is 1.1. So V partial will be what? V full into 1.1. So V full equals to 0.78, right?
Yes, sir.
Into 1.1. What's the value, guys?
0.82.
0.2, which is greater than V minimum of 0.75. So this is okay, right?
Yes, sir.
Okay. So you can take this. That means that we have 2 points, this point and this point. This point For this point, what is the capacity is equal to the peak flow. So no partial flow check. So we know this is correct, technically right. But this point is higher than the full flow. So still we do not know that whether this is technically right or wrong. So we need to go to the partial flow diagram and calculate V minimum for the partial flow condition. If that V minimum is satisfying, then we can say, okay, this point is also technically right. Clear?
Yes, sir.
Then you can take any one of these two points. Now, which one would you take? You need to provide an economical check, like cost check. Which one is the cheapest one? I think I have made it clear, right?
Yes, sir.
Okay. So, fine. So we are done. 0.330, similar to the other diameters. Same. Here, look at this. 0.000A. What happened to here? Here, cumulative peak flow is 0.615. 0.61. Which pipe base? 4 to 5. You'll see that when you do this, 4 to 5, let's go. Let's calculate this. 4 to 5, right? Yeah. 4 to 5 minus 4 to 5. Yes. What is the elevation of 4 point in between 18 and 17, right? Maybe 18.6, am I right? This
Yes,
point,
sir.
18 and 17. So sorry, 17.4. This may be 17.4. 18 and 17. 17.4. Yeah, 17.4. Okay. So what is the slope here, guys? What is the slope? 17.4 minus 17, right? So this will be 0.4. Are you following me?
Yes, sir.
Yes, sir.
Divided by what is the length of the pipe, guys? 707 again. Okay. Can you please tell me the value?
Sir, 0.0005.
0.0005. Remember what was our minimum slope? Hmm? What was our minimum slope? 0.0008, and this is 0.0005, less than the minimum. Am I right?
Yes, sir.
So are you going to put 0.0005? No. You'll have to be. You'll have to take the minimum one. We cannot take this one 0.0005. No. You'll have to take 0.0008 as a primary basis. Clear?
Yes, sir.
That's what they meant actually. So we are done up to this. In the next class, we will determine the shear elevation at different points. Okay, and then this problem will be done, inshallah. This is a very important problem. You'll have to you'll have to face this types of problem in your exam at the same time in your project. Okay.
Okay,
Any
sir.
any question?
স্যার আমার প্রেজেন্টটা স্যার একটু দিতে।
Regarding the lecture, any question?
No, sir.
Sir.
Okay, thank you very much. Have a good one and stay safe.